right, good afternoon, everyone. I'm very pleased to introduce Ani Nenkova, who recently joined the faculty at Penn. Before becoming an assistant professor there, she did her postdoc with Dan Jurafsky at Stanford. And her PhD was supervised by Kathy McEwen, and it was on multi-document summarization. So today she's going to talk to us about various prominence features and how they affect text-to-speech systems.
Hello, thanks for having me here, and I'm really excited that I get to give this talk now because this is the stuff that I did with Dan during my postdoc, and normally whenever I get invited somewhere, I don't get to pick the topic, so I'm always asked to talk about my PhD stuff. And now Chris was nice and said, just like, pick whatever you want. And I was like, okay, I'll tell you what I did at Stanford. And before I actually begin the talk, I would like to tell you a bit the context of the project I worked on so that kind of the structure of the talk makes more sense to you. So I worked on the Stanford part. I was part of two collaborations with Edinburgh. One was with a bunch of linguists who really were interested in semantic phenomena and kind of seeing what we have about this kind of information structure realizations in real conversational speech. So Mark Steedman and Sasha Kalun and Malvina Nissim annotated this big corpus with information structure things. And then at the same time, another group at Edinburgh was really just interested in improving speech synthesis. So kind of me being on both projects, I had to come up with kind of what we can learn from one and how we can apply it to the other. So pretty much kind of I'll talk about three things. One is prediction of prominence and using semantically motivated features to do this. And then using the complete most dumb features that we can integrate in a synthesis system. And I'll tell you about the experiments for this. And then since it was text-to-speech synthesis, the first part would be really only on textual features. So at the end, I'll talk a bit about acoustic features as well. So kind of this is, and I'm not sure whether I'll have time to go through all of this. So, but I will try, and I really am perfectly fine with taking questions while I talk, so you don't need to wait till the end. Sure. Should I just at least go to the first slide?
Yes, actually, I was going to ask you, since you mentioned information structure, I was wondering if you haven't already put in your slides, please tell us more about whatever theory of information structure these guys subscribe to.
So I will explain.
That's something that I don't know much about, and I suspect.
I will explain. I actually thought that you'll know more, so I was cutting out some of the slides, but I'll be happy. So at some point when I talk about features, right, I'll be happy to tell you about exactly what they annotated, and I guess it's also promotion of the corpus because it is supposed to be released for kind of general usage through the LDC. So I'll talk about this when time comes. Okay, so kind of the main motivation is really speech synthesis, even though after this motivation slide, I'll very quickly turn to kind of actually predicting prominence for speech synthesis. But of course, all of the studies on predicting prominence would start somewhere in the introduction. They would say we want to be able to predict prominence, which word should be prominent in an utterance so that we can improve speech synthesis. So this is the ultimate goal. And kind of everyone agrees that nowadays we have reasonable text-to-speech systems, and some of the kind of main remaining problems are problems with prosody. So I'll play you two clips of the Edinburgh synthesis system, and you can see how problems with prosody could really kind of make it sound like a machine said it rather than any human being said it. Okay, so here is example one.
When he did speak again, it was in a deep growl.
So we do have a deep growl, so determiners being accented. We see stuff like this, kind of problems with phrase boundaries.
If you can't see whether I'm singing or not, you have sharper eyes than most. If you can't see whether I'm singing or not, you have sharper eyes than most.
So kind of really, this is the motivation. We know that there are these problems in the synthesis system. No one in synthesis, or at least in concatenative synthesis, really cares about prosody. Can we come up with a prosody model? And in our case, kind of what I was talking about would be prominence in speech. And can we incorporate this into a synthesis system so that we can improve this sort of utterances?
Just to understand what these systems are doing, the bad ones on the slide.
Okay, so actually the systems would be doing exactly the same. Do you really want to hear it now, or can
No,
I?
the question is not about synthesis, but rather about what annotation they do before synthesis. Are they doing part-of-speech tagging, or are they doing?
So they are doing.
Are they doing parsing, or are they doing other kinds of markup?
No, you're not doing parsing. So for synthesis, you want it to be fast. So you probably cannot afford parsing and doing kind of. It depends on exactly how you want to use the system. But this system pretty much uses part of speech is the most sophisticated thing that they use.
And maybe word sense disambiguation for.
No.
No, I see. Okay. So there, for every word tag pair, there's just one pronunciation.
Yes.
That's modulo the boundary effects, right?
Well,
There's just one phoneme string, is what I mean.
yes, only one phoneme string, yeah. And yes.
Let me ask you a different question on the same theme.
Okay.
What markup is passed on to the synthesizer? So if I wanted this to be synthesized correctly, in other words, what got marked up on the A which made it prominent in A deep growl?
So the markup really is part of speech, lookup of syllable prominence, syllable level. So is it a stressed syllable? Is it a non-stressed syllable?
Okay.
But there was more of an F0 contour than you'd get just from that on the samples that you played.
Well, so this is, how many people know how concatenative synthesis works? Okay, so pretty much then you know that really there is no control. There's kind of target cost function, so there are things that you want to pretty much match. And there is the kind of how well the acoustics also match, but there is no really strict constraint. It's more like desirable matching, right? In the target cost, you really don't know kind of what exactly made it wrong. Kind of you can get errors, and out of the 10 constraints that you have in the target cost function, you don't know which one got violated for a particular example.
Right. What I mean is that the constraints presumably have more linguistic analysis than just which syllables are stressed. Because I'm sure I also heard high tones in there and pauses.
Let me show, I'll show a slide with all the constraints that they
okay,
had.
that's great. Sorry to interrupt them.
Okay.
So you're going to get around to describing the corpus from which the concatenative material was.
Why don't I actually start the talk and then I'll learn my lesson. I'll never encourage questions so early in the talk. But yeah, we'll come to this. Because I first actually, on the next slide, I want to start talking about something different, which is before going to synthesis is this task that people have been dealing quite a lot with on read speech, kind of read material. How do we predict which elements are prominent and which are not?
Just touch that regularly.
Okay. So the task of pitch accent prediction, prominent prediction, we have a string that we want to give to the machine, such as you see women going off to worse as men, and we want the machine to predict which of the words are prominent, such as see women going worse, well, and men. So kind of uppercase is prominent, lowercase is non-prominent. And so we're doing this on the word level. Some studies kind of do the prediction on the syllable level. In the task that I'll be talking about, it's really word level prominence that I'm concerned with. And if we want to use this prediction for text-to-speech synthesis, then the prediction has to be from textual features only. So you're not analyzing my speech, asking what did I make prominent, it's which ones should be made prominent given the text that is given to the synthesis system. So this would be the first part. I'll only talk about textual features, and then towards the end, I'll say a bit about acoustic features. And probably most of you know kind of Julius Hirschberg's work that was saying rather than coming up with handwritten rules, why don't we use part of speech, and it can give us quite a good system for predicting. Of course, we can all figure out that function words are reduced, content words are prominent. So this is one obvious distinction that part of speech can help us with. And in fact, most synthesis systems today use pretty much this part of speech distinction to decide on what is to be made prominent and what is to be reduced. Then in later work, capturing this idea that words that are more surprising in a given context have to be pronounced more carefully. So unigram probability would be helpful, and unigram probability, like the higher the unigram probability, the less likely it is that the word would be prominent, indeed works significantly better than part of speech for predicting prominence. And in Shimei's Penn work, actually, she spoke a bit about lexicalized features, actually using specific words in the prediction. And they work kind of well, but in their papers, they're saying, well, lexicalized features are not likely to generalize across genres, so we won't pay much attention. So actually, I will be talking more about how far you can go with just using one simple lexicalized feature. And pretty much all the recent work has been, okay, we have come up with all the possible features, now let's try to do fancier and fancier machine learning on the same problem and see what fraction of a % better we can get. So it seems that at this point of research, it was time to actually try to integrate stuff into synthesis system, because results haven't been going dramatically better. And the question in our work was, what combination of features that we know exist can we take? And of course, integrate in the synthesizer. The faster and the cheaper you can compute the features, the better, because you don't want to wait a day for your sentence to be produced. And then also, as I was saying, we had this very richly annotated corpus with information structure annotation. So givenness was one, and I think I have a slide. I guess most of you are familiar with discourse entities. For discourse entities, they belong in the hierarchy of how given or salient they are. So things that are mentioned for the first time in a discourse is new information. Things that have been mentioned in the discourse already are given. And there have been a lot of theories that the givenness of an entity would actually be realized in the acoustic signal for referencing this entity. So there have been more laboratory studies that show that given information is less intelligible if you just cut out the word and play the word. If it was given information when it was pronounced, it's less intelligible, it's shorter and less loud. And then also the question that we wanted to address was, are lexicalized features really so stupid an idea? And as I said, the answer was actually you can get pretty much the best performance you can hope for with just one simple lexicalized feature. The corpus that had been annotated was switchboard conversations. So these are telephone conversations. These were, I don't remember anymore how many conversations there were. There were about 15,000 tokens, I think 20 conversations. And the annotations that we have were actually of two types, both binary prominence, prominent, non-prominent, but also in their kind of later annotation layers, Edinburgh added nuclear accent and kind of more diverse types of accents. I haven't used this, so everything that I'll be telling you here is about binary prominence. And kind of the one surprising thing that we can see is that the majority class is actually non-accented. So this is natural speech, and the majority of the words are not accented. This is not the case for red speech, when the kind of majority class is 70-75% accented words. And experiments that we did were with a decision tree classifier. It's faster, it kind of works well for the task, and at the end I'll show you some other results with conditional random fields. But kind of really this was part brute force. From the features that we have, which subset of the features should we take to include in the synthesis system that give the best prediction in terms of accuracy for binary pitch accent. So it was an exhaustive search of combination of features from 1 to 5 to see which one would give the best classifier.
Is this by any chance the marks that Steve Greenberg did in '97 on the switchboard, or is this another?
No, this is, so the initial set of annotations was done in University of Washington by Mary Ostendorf, and then...
So these are Toby type markings?
No, they were just binary.
Just binary?
Yeah.
Okay.
And in Edinburgh, they kind of had a bigger set, but it wasn't Toby. So it was more nuclear accent, emphatic accent, strong pre-nuclear accent. So the Edinburgh, I don't know how they came up with that. And in a way, this is why we decided not to use the full Edinburgh annotations, because they didn't
You converted those to binary prominence, or you used another?
binary, yes,
You
prominent.
converted
no.
them to binary,
Yes.
prominent or non-prominent?
Yes.
Yeah, actually, if I were to hazard a guess, I'd say that this is actually the data that Stephanie Shattuck-Nagel annotated, along with Mari, and Jack, you paid for that too.
Yeah. Well, I'm interested because they had a different concept of prominence marking than Steve did.
Right, no, that is true. No, this is the data, and in fact, you can confirm it if you tell me that the data not only has the prominence, it also has prosodic phrase boundaries. If it does, then it's exactly.
The prosodic boundaries were not in the initial UW data. They were added by University of Washington.
Okay, because the number of conversations you're telling me, that sounds about the amount that...
60, so UW had 60 conversations,
Right.
and since Edinburgh were doing way more annotation on top of them, they only got to annotate about 20 with all the extra stuff that they were annotating.
I think that's the same data. Okay.
I mean, I'm sure that Dan Jurafsky would be able to actually tell you. I don't know if this predates me.
One more real quick question, because I see you're about to pitch in. Because the majority class is still only 58%, there are a lot of words being marked as accented, and so I presume a lot of those really shouldn't count as accented words, but only accented syllables. A word that has some accented syllable, just because you have, an ordinary grid stress pattern. In other words, there are words that you would write in italics if you were transcribing.
No. So there are
Italics,
emphatic.
all caps.
Yeah. So you're saying it's kind of emphatic. So it's like super strong.
I'm saying it's
accent,
not
or-
that you're accenting more than just the emphatic ones.
Yes. Yeah. So really, it's just.
So for example, I
prominent,
just said
so-
you're accenting more than just the emphatic one. So maybe more is emphatic, but accenting also was stressed, but only the ac part. I mean, to say that was an accented word is funny. It was an accented syllable, ac. It's not because the whole, maybe you want to say you spread it over the whole word.
It is spread over the whole word. So if a word is prominent, so I just said if a word is prominent, it's marked. Word prominent and marked would be marked in my utterance as
Got it.
prominent.
Okay, thank you.
Okay, so actually on the 20 Edinburgh conversations, there were givenness annotations for given, which means an entity has already been mentioned. So for example, a pronoun they would refer to all the information. New is entities that are introduced in the discourse for the first time. And then mediated are these kind of intermediate categories that are semantically related to an entity that has been mentioned before, but is the first mention. So for example, if I say, I bought a car today, the seats are really comfortable, the seats would be mediated because I haven't talked about seats, but I kind of, by mentioning a car, evoked, like all the components. So, and kind of here you see the example, they have all the water they want, they can actually pump water. And this is kind of the canonic example that you would like to see, and the predictions about information structure would kind of lead you to expect that all the information is not likely to be prominent. So all the information, the old reference to water is not prominent, and something else is made prominent in the utterance. With the focus feature, which is the other kind of information structure features, which is the one that actually is kind of inspired by a lot of linguistics work, but is really kind of, Edinburgh came up with exactly what they think contrast should mean. So what is contrast? Contrast is, so here, only he showed up. In linguistics, kind of the literature on narrow focus, you have a lot of these sentences that have adverbials such as only and just that are supposed to be focus-inducing particles. So the word associated with them is likely to be the focus and to be made more prominent. So even a pronoun like he in a sentence like this, only he showed up, he would be prominent. So this is, I guess, one of the adverbial types of contrast. There is the other contrast where you have two semantically related entities that are contrasted. So you see women going off to war as well as men. So women and men are contrasted. And then these annotations, they had guidelines. So there were adverbial, contrastive, and this was this category other, because the annotation was done reading the transcripts but also listening to the audio. So sometimes there would be something like the plate is extremely hot or something like this, and there is really no class of contrast that covers extremely, but they hear in the audio that the word is made emphatic, and they just mark it in the class other. So in a way, this was, and I'll show you at the end, probably this was a problem with the annotation, having both semantic theory and listening to the audio, because sometimes it's kind of hard to tell apart what the prediction for the theory would be.
There is this Czech theory of focus and topic. You're not using it, even though you talk about old and new here.
So I'm using, so pretty much, there are papers, I think Mark Steedman is on both papers. So one is what they this thing in the Edinburgh papers is called contrast with K, or narrow focus. And they have a paper on this annotation, like fully devoted on the annotation of why they made the decisions they made. For this, really, they just say we adopt kind of the Ellen Prince givenness hierarchy, and this is what we annotated. So in their papers, they have a lot of discussion on the parallels with other theories of information structure, but this is what had been annotated in the corpus. So it was their decision, they did the annotation. This is what I worked with. So I can only tell you, if you had this kind of annotation, what I found out about the relationship between this and prominence. And I feel the more I talk with people that actually have strong kind of opinions about linguistic theories, the more they say, well, your results weren't that strong because they didn't annotate the right thing, which is possible. I can only tell you kind of what this annotation kind of shows. And there were a bunch of other annotations that were dialogue act and animacy that weren't that interesting, and I won't talk at all about from here on. And of course, there were the cheap features that you can get, kind of the non-semantics of part of speech, unigram probability, bigram probability, TF-IDF, word length, distance from closest pause, and things like this. So if you remember from, oh, yeah, and here is my lexicalized feature that kind of ends up being very useful, contrary to kind of intuitions. So what if we kind of take the view that's further just removed from linguistic theories and say, information structure doesn't matter, prominence is really a property of the word. Certain words are just prominent whenever they're pronounced. And if we look at a big corpus, and for each word we collect how many times we saw it being realized as prominent and how many times we saw it as being realized as non-prominent. So we can get the probability of the word being prominent, right? And the problem, if we took these counts, would be, of course, because of the Zipfian distribution of words, we'll see a huge amount of words that we only saw once. So they'll have a probability of 0 or 1, but there'll be really no information in this 0 or 1. So what if we kind of still compute this probability that we get from the corpus, but we also kind of only keep the probabilities that are based on enough information. So what if we run a binomial test and say, okay, we saw this word n times, k times this word was prominent. Is this kind of consistent with the hypothesis that we have no idea whether the word would be prominent or not, which means that we have no idea which way it would be realized, would be probability of 0.5. So if the binomial test turns out to be significant, only then we'll memorize the word and its probability of being accented. So this is really very lexicalized and very simple. As you can imagine, there's only a short list of words that actually end up in this accent ratio dictionary for which the test is passed. For some majority of words, really, there is not enough data. For other words, they just don't have a preference for a class. They occurred many times, but the probability was close to 0.5.
Right. How do you distinguish a word that didn't appear here from a word for which k is 0?
So here, this dictionary is built only for the words that we see appearing. And then later on, when we kind of run the classifier on new, when we do the training, each word that we didn't see in the dictionary would be assigned probability of 0.5. So it's like we have no clue where this word would go.
I see. Okay.
But this is really the building. So this one, really, each entry, we have the count. So we have an entry only for the stuff that we saw in a big annotated corpus. And
yeah, no, I've got it. You say 0.5 default on the slide, and I've been,
right, yeah.
You didn't write it as the second branch of the equation. No, I got it. Okay. Would an alternative be to back off to the accent ratio for the part of speech tag?
They actually, yeah, so David Beaver really wanted to do this, but yeah. I kind of didn't want to, and it seems like more variations of the same theme, like I thought it was pretty cool that we got these results, and I wanted to move on to something else. So there were people who wanted to do this. I said, I will not do it, and no one else did it, so here we go. Results. So this is, remember, tenfold cross-validation, decision trees. Accent ratio is single feature used, so the only feature used in the classifier. 75.5% accuracy. Best reported results on conversational speech is slightly above 76%. So this is already kind of very high. You can see that...
That means that equation you had before predicts accent in 76% of the case.
Not really. So let me...
So what does the 76?
Okay, yeah. Let me explain. So in the previous slide, I said how we came up with the accent ratio dictionary. So we have entries and we have a number, which is the probability. So we go to a new text, and this is what Jason was asking. So for a new text, we want to assign the accent ratio features. For the words in the dictionary, we just put whatever is in the dictionary. If we have a word that's not in the dictionary, we assign probability kind of 0.5 as the feature, which is we have no idea what will happen with this word. So this is the features that we give to the decision tree classifier. And the classifier that is learned is that any word that has accent ratio below 0.38 is not accented, and any other word is accented. So this means that pretty much from our accent ratio dictionary, we have a list of stop words. So these are the words that got an accent ratio below 0.38. And these would be non-accented, and everything else would be accented. So stuff that we haven't seen has probability of 0.5, and the classifier that gets learned is that anything with accent ratio above 0.38 would be accented. So it means any word that's not in the dictionary would be by default accented.
Yeah, and what's the 76%?
So the 76% is if we apply this. So kind of we look at the accent ratio feature and we say, okay, so if it's below 0.38, it's not accented, otherwise it is. And then we look at the conversation and ask a person to tell us what are the binary. So in 75.5% of the cases, the prominence label predicted by the accent ratio dictionary is what people annotated in the text. So it's kind of reproducing the annotation for the given conversation. And normally, I mean, this is the usual actually metric for all the literature on prominence prediction. This is what they report accuracies.
And to put this in perspective, the do-nothing baseline is 58%.
58%. So also notice the same thing with red speech, the baseline, do-nothing baseline, accent everything is 75%. And the best results are about 86%. So this is actually much bigger improvement over the baseline than in red speech. And you can say that, for example, part of speech is actually a better baseline rather than do nothing, because you know that kind of prepositions and articles will not be accented. So this is higher. This part of speech baseline, 70%. So it's even better than this. And these are significant differences. So 75 on accuracy is significantly higher. And this is Shimei's pen kind of years ago showed that unigram probability is significantly better than part of speech, and this is even better. Oh yeah, so I guess this is what I just explained, exactly kind of what the classifier did. And we can kind of go back and see how the linguistic features did. If you only use the two linguistic features as a single feature for the classifier. So given you 64%, the contrast narrow focus features 67%, so quite poorly. And what happens when we start combining features? So of course you probably want to use more than one feature in your classifier. Pretty much in all combinations, the classifier that had accent ratio as a feature performed best. And the one feature that was most useful, so led to the highest improvement when added to accent ratio, was the narrow focus feature. And the overall best, so this is the overall best classifier was accent ratio, focus contrast, TF, IDF, givenness, and distance from last pause. The accuracy is 76.6%. So it's 1% improvement, adding two kind of gold standards. So these are gold standard annotations for focus and givenness, TF, IDF, and distance, and you only get 1% improvement. And you can say, well, this is still improvement, but I don't know, it's kind of small improvement, especially kind of, I'll start talking about, and we don't know whether this 1% would make any difference when we use it in a system. And unfortunately, I cannot tell you whether it does, because we messed up our experiments with the synthesis, but I'll tell you kind of what I know should be done. And here is like, if you want to see how the performance, so this is adding more and more features. So these are the performance of classifiers based on single features, two features. So the top line is the classifiers that have accent ratio in them. And you can see that it's pretty flat line, like you add more and more features and there's like tiny improvement. The one below, so the second highest is without contrast, so without the focus feature. And this one is what happens when you use neither contrast nor accent ratio. Like if you use the kind of traditional features. So way lower performance even when you start getting more and more features. And kind of one of the puzzling questions was, why didn't the information structure features help as much as we were hoping them to help? Well, for givenness, apparently one obvious explanation is they have restricted applicability. So the givenness in the Prince hierarchy of givenness only apply to entities. So this annotation applies to pronouns and nouns. And there is way more in speech to be annotated. So givenness would not help you figure out what to do with verbs and all other sorts of things. Moreover, it turned out the givenness, kind of the general kind of Prince theory, even originally predicts that the information status would influence the syntactic form of the reference. So all the information is much more likely to be prominalized. And we know that pronouns are much more likely to be not accented. So in a way, we have a cheaper feature, which is part of speech that can tell us. And if you look at this table, you can see that of the pronouns, of course, all of the pronouns were old information, a bunch were mediated information, and then kind of this part of givenness is already explained by the syntactic form, so you don't need the expensive version of given new. And then you probably in this table might see another possible problem. We really don't know what linguistic theories say about mediated information. I only know about one paper that talks about mediated information, and this paper says that it depends on the semantic relationship that the mediated entity has with the already mentioned information it's linked to. And as you can see, of all the nouns, more than half are actually mediated. They're not new or old, they're mediated. So really, from linguistic predictions, we don't know, like anything can happen.
I have a question about restricted applicability. So should you have integrated features like about the next word? So if that would expand the applicability of the givenness, right? Because if you knew that the next word was a noun and it was already given, then that might influence your accuracy, the determiner, for instance.
So yeah, right, but still, like if you see, these are the performances. So here, one of these, so these are the best classifier for a given number of feature. So whenever like adding to givenness another feature was less than this, and you can see how much more you can go if you actually get the accent ratio feature. So yeah, you can do it, and yes, of course, you get better performance. It's not like it would be stupid to get only one feature, but still the performance is less than you can get if you get.
So I guess my question is, did your features incorporate information about the surrounding words, or just the current word?
So in the numbers that I show you now, no, it's just kind of given word. With decision trees, taking context turned out to be helpful. So at the end, I have some numbers. If you do conditional random fields where you take the preceding and following word, you get some improvement, but tiny improvement.
And that's still not doing global decoding, right? So
No. So this is absolutely local.
yeah.
Yeah.
I mean, the advantage to doing something like an HMM is you could capture questions like, is it unusual to have 2 or 3 unstressed syllables in a row?
Right. So I did do this actually, and it wasn't, the improvements were so little, it was 1/3% that we felt it's not worth, I mean, there have been so many papers, and we got 1/3% better. And it's known, it's even like the Shimei Pan thesis from 5 years ago, she shows that if you have an HMM,
Well,
you get.
HMM on a word-by-word basis, is that right?
Yes, yeah.
Yeah, so I would tend to do it on a syllable-by-syllable basis because that's the level at which you have phonological clash and lapse. So I understand that then, given those, that you can't train those predictions entirely from observed data, but that's why you have a forward backward algorithm. In other words, you don't know which syllable got accented if the word was stressed, but you may know something about that from the pronunciation dictionary. And then you can make predictions on individual syllables and then evaluate just on whether the word was stressed at all.
I cannot say whether, I'm not sure whether what you're saying is true, whether doing it on the syllable level gives you better performance. So I don't know. Probably this is not the case, since if this were the case, all the people who are doing prominence prediction would you wouldn't be able to publish your stuff on word level, and there are as many people doing prediction on word level than on syllable level. So
I would go the other way. I would claim that what you need to do is get some sort of constituency structure and expect that there will be one prominent word per phrase.
Although,
First approach.
yeah.
the phrases are destined.
So how do you get the your focus contrast feature?
Manually annotated. This is in the data.
Right.
So this is.
In a real-world application, you have to predict that.
I have some results on how you can get to predict it. Since I'm going so slow, I can tell you something to. So it turns out that if you decide to use, so I have a student. Okay, if you want to predict it from acoustic features, so if you have someone speaking and then you want to predict the which elements are contrastive or focused or not, it's almost impossible based on acoustic features. And it turned out that the problem is that focus was so broad. If you break it down into the different categories, such as adverbial contrast or contrastive or other, which is this kind of just emphatic accent, turns out that adverbial and other, actually you can get pretty good accuracy based on acoustic features in prediction. But the other categories are very hard to predict based on acoustic features. And this is an interesting point that is kind of unexpected. If you look at what linguists would tell you about all the information, normally they would say that all the information is reduced and less clear. But if you look at this table, kind of seeing how the new and old information is distributed over nouns. Of course, we only want to look at the nouns, because if we look at the pronouns, you get this very clear distribution, but then it's kind of not so interesting because you can just get it by this realization form. So for nouns, we get 65% accenting overall. And if you look at the old nouns, it's pretty close to 65. But what happens is new information is more prominent. So, and if I don't know kind of what this means for linguistic theories, but if you look at this kind of binary annotation, it seems that if you have a theory about the differences between given and new, it's not that all the information is reduced, but rather than that new information is made more prominent. So the rate of accenting is 73 on new nouns, while the overall accenting rate for nouns is 65. So here, if you are curious to see examples of what's in the accent ratio dictionary, so low accent ratio are things like which you would expect, but also things like some, being, thing. So this kind of part of speech would not give you kind of this information. So being would probably be some sort of verb, thing would be a noun. So also verbs, state, supposed, said, say, wanna, all these are low accent, so they're not prominent.
They're sort of related to the notion of light verbs, right?
Yeah.
I mean, this is an interesting diagnostic for light verbs.
Mm-hmm. Yeah, and I guess if there were a system that could tell you kind of semantic content, kind of it would suggest things like this, you know, for the thing, and then minutes, little, anything, you know. And then what gets accented? High accent ratio words. So actually, anyway, yeah, so this is actually capturing stuff about phrasing, even though we are not doing phrasing at all. These words here are words that normally appear in a single intonation phrase. So they'll carry the accent just because they are the only thing in the phrase. They're also the focus-inducing words like to, also, else. They are significantly more likely to be prominent. And there are a bunch of intensifiers, like the things that you would expect that anyone who speaks in a more or less emphatic way would make rather, it's like a major improvement. It's a really poor performance. Or yeah, this is super and great and things like this. So it's kind of interesting. You think it's really a dumb feature, just memorizing, but then if you look in a way, you can see, if you wanted to get this sort of dictionary by more sophisticated methods, you could come up with a bunch of tasks like light verbs and intensifiers and words that tend to form one intonation phrase.
Well, something else you could do is, which is better than what David Bieber and I both thought about part of speech. It looks like it's not necessarily about part of speech, it's about the semantic category of the verb. And so you should be able to smooth over clusters of words with similar meaning. You get those clusters either empirically or from a thesaurus. But that should allow you to look at words that where you only have a few occurrences and weren't able to get the binomial likelihood ratio. Yeah,
I actually think this probably, I'll come back to this a bit later. Is it robust? I'm going really slow, so I want to speed up a bit because I want to tell you about the actual synthesis experiment. So does having the binomial cutoff help? Yes. If you only kind of memorize words, regardless of how many times you saw them, you get less than 2%, more than 2% kind of worsening of results. Can you use it across genres? Yes, you can use it on news, the accent ratio dictionary that we got from telephone conversations, and get about the same performance as the best classifiers on news. So kind of it kind of seems that the worries that people have about lexical features are actually not so worrisome. And so let me play you two more examples of kind of what would happen if we integrated this prominence model in a speech synthesis system.
If you can't see whether I'm singing or not, you have sharper eyes than most.
And then once we add the kind of prominence predicted by accent ratio only.
If you can see whether I'm singing or not, you have sharper eyes than most.
And now I have to figure out how to tell you in 10 minutes about the stuff that we did. So the question in integrating this model of the prediction is, how do we modify the target cost? And how do we label the unit selection database? Well, we can label it easily because we have this really cheap feature. And we can't label the database for emphatic accent, though, like if we want to have different levels of accent. So for emphatic accent, what we did was ask the question, if we could mark up the database for emphatic accent, can we get more natural synthesis? So instead of marking it up, we collected a bunch of sentences like this. So the voice talent read contrastive frames such as, it was Paul who did it. No, it was Eliza who did it. It was Eliza, not Paul. And the nice thing is that here you can just use a name dictionary and create as many frames like this for the voice talent to read as you want. And all of these names are marked as emphatic ones. And the question is now, can we use the pitch accent prediction and the emphatic accent and integrate them and get better sounding synthesis? And so here is what the Edinburgh system had in their target cost. So they have kind of acoustic and these two really shouldn't be here. They should be in the joint function, the context, but anyhow. So they have position in the syllable, position in the word, part of speech, position in the phrase, stress, boundary tone, and then here are, so these are the weights in the brackets that they had in the target cost function, and pitch accent and emphatic accent are added to the cost function. And these two clips that I played, this is the difference. So it's the same system, but we have the other layer of annotations, which is pitch accent and emphatic accent, and these two elements added to the target cost. And first, it turned out that the emphatic accent actually really made possible to synthesize emphasis. So people were asked, if I play you a sentence and I pick a word that I want to make sound emphatic, can I play this sentence to you and ask you which word was the most prominent? Will you pick the word that I had assigned to be the most prominent one? So there had been previous experiments like this, and the rate of recognizing the intended word was 0.28, and here we had 8 times above the chance level finding the word that we intended to make prominent. So this is the listening experiments were sentences like this. When he did speak again, it was in a deep growl. This is shown as words without, of course, the capitalization. The subjects hear the clip and are asked which was the most prominent word, and they pick one word. And these numbers here will tell you of all the subjects that listened to the sentence, how many picked that given word. So here, the white kitten had nothing to do with it. 21 people listened to it, 17 picked white, 1 picked kitten, 3 picked nothing. So, and white was the target prominence. And then also people did pairwise comparisons, so they would hear 2 versions of the same sentence, and we would ask them, which one do you like better? And the pairs were between the default system, the system with pitch accent only, the system with emphatic accent only, and the system with combined pitch accent and emphatic accent. And so for pitch accent, news, of course, there is little space for being emphatic and news. So for this, we only tested the addition of pitch accent, but even for news, the preference was stronger for the model that included pitch, accent, penalty, and the target cost. For fiction, where the fiction sentences came from kind of works of fiction where the author had orthographically marked. Actually here for fiction, really, these are just pitch accents. So the next table would be on emphatic. So, but for fiction, even more significant preference. And then I won't even talk, like we had child-directed speech, but I don't have time to talk about it now. And the same with emphatic accent. So people actually really like the addition of the emphatic accent. And let me play you some clips. So the first one would be the default system. The second one is adding pitch accent. And the third one would be adding pitch and emphatic accent. Here we go.
If you can't see whether I'm singing or not, you have sharper eyes than most. If you can see whether I'm singing or not, you have sharper eyes than most. If you can see whether I'm singing or not, you have sharper eyes than most. You should not go on licking your paw like that. You should not go on licking your paw like that. You should not go on licking your paw like that.
Emphatic. It's and so what we wanted, if you remember, I told you in the beginning that the system actually already had part of speech. And when we were setting up the experiment, we wanted to say, okay, now we have a system that has higher performance than part of speech for predicting pitch accent. Do we get preference in the, and do we get improved synthesis? And we did get improved synthesis, but only, and if you notice, like I didn't speak much, these were huge subject, like there were 54 subjects who did 30 minutes of listening each. So this was a big experiment. And then kind of we wanted to say, hey, really, if you have significant improvement in accuracy, you have significant improvement for synthesis, which unfortunately turned out to be a conclusion that we cannot draw from our experiment, because part of speech had different weight than the pitch accent model with us. So kind of really, if we want to draw this conclusion, which would be the neat thing, and I'm kind of planning to do this, kind of to say, if we have differences in accuracy, do these translate in difference in synthesis quality? You want to have these two with the exact same weight and run the synthesis with only one, then remove this one, plug in the other, and see whether you'll have improvement. So now we know that the pitch accent, our cheap pitch accent can help you, but we really cannot claim that it's better than part of speech, just because the kind of, we didn't control enough in the experiment. But, oops. Weird that I don't notice it. And I want to show you this. So kind of, why do I care? Why do I want to show you that there are differences in synthesis quality? Well, remember I was telling you that the more, regardless of how many features you add, you kind of get fraction, 1/3% of improvement. And you can say, well, maybe you just simply cannot do better on this task. But it might be the case that pretty much how much you can measure using accuracy, we have reached this ceiling. And here is a slide that kind of indicates that this is probably the case. So when we speak, there is variation. So if I read a text, I'll make prominent some words. If you then read it, you'll make slightly different words prominent. So these are both acceptable renditions of the text. And so how well will I do? So kind of if I'm the predictor of your text, how well will I do in predicting your accuracy? And it turns out that if you do this with red text, which is much more regular than conversational speech, the average human performance, so kind of the rendition of one person's rendition of the text compared to another person's rendition of the text, The minimum is 79%, the maximum is 85%, the average is 82%. These are for 6 speakers, so each one paired with each one. And this is for read speech, so it's very likely that pretty much any number above this wouldn't be meaningful. What does it mean to have an accuracy above what 2 humans would agree on? So the reason why Dan was really excited about doing the listening experiments was, okay, now we can take 2 different prediction methods that have about the same accuracy, and we can test, would they make difference, would they have different output when we plug them in the synthesis system. And also, if you want to say I have a significantly better than inaccuracy system, the way we got with the accent ratio, it's kind of fine, but unless you find an application where you can show that this difference can be shown, probably it's kind of not big deal that you got 2% improvement or 3% improvement. So this is some stuff that I probably will redo because I am interested in seeing how the accent ratio feature compares to the part of speech, say. And let me just tell you that adding, using more sophisticated machine learning and using acoustic features does not improve by much. So the best result with using, adding in acoustics and adding in better model, the best result was 78%. So this is from 75. So it's 3%. So if you get in acoustics, you can get way bigger improvement than adding in more textual features. But still, the improvement is not big. And again, this is why I showed you this slide with the human-to-human performance. It's probably time to, if you really want to pursue this task further, have to come up with a different evaluation rather than accuracy.
What does it mean putting in acoustics? You're getting text, so is it like that A is always, I don't know.
No, so this is what if we forget about the application with speech synthesis? Or even if we don't want to forget about it, what if we take the synthesis database? There we have the predictions, we have the text-based information, but we also have some evidence of what the voice talent actually did.
What the voice what?
The person who recorded the database for the synthesis.
So we know that this person happens to like the word table, so...
No, this is the actual acoustic recording.
Right.
How do you use it? Maybe you should tell Fred that.
So say we completely forget about synthesis. We take our telephone conversations.
It's a labeling task.
Yeah, so now we want for each word, we can get a bunch of acoustic features. So we can measure, say, energy and F0 stuff. So you measure on 10 millisecond intervals, and then you can get, say, the average F0 over the word. Yeah. Or the difference in F0 between the beginning and the end of the word. Or the standard deviation of F0, or the highest F0. So these are acoustic features, and hopefully some of them will be better evidence. So it's not what are the possibilities of this word being realized there for this specific person, for this specific utterance, what happened. So ideally, you would actually expect much more help from the acoustic features because they're real measurements of the signal that the person produced. The classifier based only on these acoustic features is in performance about the same as the accent ratio feature. And when you combine accent ratio with acoustic features, you get only 3% improvement. So, and it turns out that if you want to predict the information structure categories, really, you cannot do that well. So let me show you just this one slide. Well, I'm over time now, so kind of I'll just briefly, quickly summarize, saying that if you go to acoustic features and you want to predict given new versus mediated, so you want to distinguish each category from each other category, you get this very weird result. So this is unbalanced data. The hardest to distinguish is new nouns versus old nouns if you only use acoustic features, which is, you would expect that the differences between these would be the biggest. And actually, the best performance, which is not, so this is 50% baseline, 64% almost, you can distinguish new versus mediated, where normally you would consider mediated as a type of, so kind of acoustically, there are some significant differences, but they're in no way in the direction that most theorists would predict the distinctions would go. And for contrast, really, it turns out that it was kind of an error to lump together different types of contrast context, and it's much better to acoustically predict adverbial and other, which is the symphatic accent that's not really related to semantics. And so this is a bunch of people. I couldn't really list everyone who, but you can see the people who have worked with me on the various aspects of stuff that I talked about. So if you have any questions.
This I may not understand this well enough. Is a mediated noun with reference to an entire conversation or just to that utterance?
Entire conversation.
So the mediate, as you move through a conversation, all nouns related to previously introduced nouns are mediated.
As long as the annotator remembers. So pretty much this is the annotator's working memory. Yeah.
And so in Switchboard, for example, that's 5 minutes worth of speech, or 2 minutes per person, that you're tracking through. And you're doing that side independent, one conversation side being scored with it seems to me that mediated is a tricky category if you follow. I mean, it's a proper procedure, but it seems a tricky category because the deeper you go into a discourse or conversation or dialogue or whatever you're working on, the harder it's going to get to determine the mediatedness, and this could have a very strong effect on what's reduced.
I guess exactly this is what we're seeing. It's kind of, we have no idea where mediated would go. Some mediated is accented, some is not. Then
the tendency to reduce a noun that is the fourth or fifth related but not exactly repeated piece of information, the tendency to reduce it could be very, very much higher and very hard to track by the chain of mediation.
this story is very consistent, I guess, with the numbers that I was showing you, but really kind of people have been focusing on given and new, and mediated was kind of, yes, this thing that exists, but we don't need to talk much about it. But yeah, kind of first, most of the nouns end up being in the mediated category, and then it's much more difficult to handle.
And it's quite possible that in dialogues that there's a reset of the given mediated new.
Yeah, I guess David Beaver is kind of really interested in kind of continuing the work on this, because it's kind of up to a linguist to take up kind of what comes out of a realistic conversational speech and come up with a theory that could kind of explain all the results that we got here.
Push the button, please.
Okay, go ahead.
Do you have examples of words for which the classification changes after you introduce the cutoff on the binomial coefficient? You said you get improvement, but which words are affected?
So the words that
That have a frequency close to 0.5 probably, but I'm just curious.
I guess what Damias wants to know is, give examples of words for which k by n is bigger than 0.5, but they don't meet your binomial test.
I will not be able, so I could look them up, I cannot say right now. We actually, this was something interesting that we wanted to look about, because this would be kind of real variation. For these words, you actually have to come up with a theory, so something should be making them go one way or the other, right? So this is something I looked at, but kind of a long time ago, so I cannot say right now which were the words.
When you evaluated your system, asking people what utterances they like better, you played them isolated sentences, right? Or did you play
Yes,
them longer utterances?
isolated sentences, sentence by sentence, yeah.
Would it be probably better to play longer utterances, would you agree, because of the givenness feature?
So this is, I did have it on a slide somewhere, actually, kind of, this is future work. Actually, no one has worked, I guess Alan Black at CMU is the only person that I know about who is actually working on synthesizing kind of full paragraphs or full stories rather than sentence by sentence. All of the other synthesis work I'm aware of is really sentence by sentence. They do absolutely nothing. Yeah, so this will get more interesting, and I don't know whether they have published stuff, but a student of Alan Black's was saying that they were doing some experiments, and it seems that even some sort of approximation of givenness seemed to give you better synthesis. They were saying, we're not sure how to evaluate it, right? Because you have a slight change, you can hear and like the change, but then how do you ask your subjects to tell you about this change, specific change, rather than the synthesis over the entire snippet of text that they hear.
For the features like givenness and focus, do you know by any chance how many annotators annotated the same sentence, and when they do the annotation anywhere, and whether they compare the inter-annotator?
So these papers, I think Sasha Kalun was on both papers, Edinburgh papers. They have one paper on givenness, one on focus, and there they did the kappas, and they have like reasonable inter-annotated agreement. I have not been involved, but I have looked at these papers, and they seem like they did what any annotation project is supposed to do before they proceed to annotating more data.
The result you showed with the acoustic features and the classification didn't make much sense to me. Do you have any theory or hypothesis as to why you versus old compared to the kind of results that you're showing with the acoustic features?
What exactly about them?
You're getting a better classification for the, I guess you're getting worse with the old versus new relative to the mediated, and that can...
Oh yeah, no, this is what I was saying. This does not, this is why I brought it up as a problematic thing, like why is it the case that this one, yeah. So we actually, it turns out that if you want to do classification where you do the normal thing and merge new and mediated and try to distinguish versus old, you get much worse results than if you lump mediated with old and try to to classify based on acoustic features. This is, as I was saying, part of these theory, part of the interesting stuff that I see is that it's contrary to any expectation. So both for the focus and for the given new, you have some expectations, and what is happening in conversational speech goes absolutely contrary all of the expectations we might have.
Doesn't that put into question the labeling of mediated and where it should really fall?
I don't know, like I personally think that the kind of the contrast, the focus labeling probably was a bit too, kind of wasn't precise enough. They tried to cover too much and lumping too much into one kind of semantic category just made it impossible to deal with. My impression with given you is that this is what has kind of people have entertained for a long time, and kind of with syntactic form and placement in the sentence, this type of differences have worked pretty well. So why they're not working with acoustic realization, I have no idea.
Also the priors are different, right? You say that in mediated as...
So these two are on downsampled, so these are 50-50, so
Oh,
the
they are.
baseline, so for this slide it's 50-50, yeah.